Hey guys, here's a quick tutorial on how to do a rate law problem. Specifically, this is called the method of initial rates. So the first thing you should recognize with these kind of problems, these are going to be your level 33 problems. Rate law is not the same thing as what you did in level 31 with rate expressions. You should understand that the rate law really just has some important factors that differentiate it from those rate expressions. Number one, rate laws are experimentally determined, and we'll get to that in just a second. Quickly, the general format for the rate law is rate equals K. It's a constant. All you need to know is called the rate constant. There'll be problems where you'll have to calculate the rate constant. It's going to be multiplied by the concentration of, in this particular problem, A and B, or X and Y. I should change that to X, Y. That's a typo. And then those are raised to some powers. Those are called the orders, and we'll see what the orders are in a minute. You should understand that rate laws are experimentally determined. This means that scientists have to do experiments where they measure the rate in order to get this information for rate. For number two, the point is that you don't include products in a rate law. That's different from the rate expressions where we might have a rate expression for a product. And then finally, you don't include the coefficients of a balanced equation. We ignore those, unlike the rate expressions where we included them. Okay, what is this order business? Okay, order is basically a unique feature for a reactant. So each reactant has its own order, and that's going to dictate the effect of that reactant on the speed of the reaction or the rate of the reaction. You can also figure out the overall order by adding up all the individual reactant orders to give the overall order. So it's just addition when you're figuring out the overall order. So here, let's look at this problem. We have X and Y as our reactants. The first question A is, what is the order of reactant A? So what I'm going to do is I'm going to look for two experiments in the data. The particular experiments I want to pick out are an experiment where X is changing and Y is not. So you need one of the reactants to be constant. In this comparison of experiment 1 and 3, you see that Y is constant where X is doubling in concentration. So what does that tell you? Now we got to look at the rate information. What's happening to the rate? Rate is staying constant. When you compare experiment 1 to 3, the concentration of X doubled, but the rate did not change. It stayed at 4.0 mole per liter second. So why is that important? Well, it tells you that the concentration of X is not affecting the rate. So if you change the concentration of X, or this could be for any situation, if you change the concentration of a reactant and the rate does not change, we say that the order is 0, meaning it doesn't have any effect on the rate of the reaction. So that's your first answer for A. The order of the reactant for X is 0 order. So we don't include reactants that have a 0 order reactant in the rate law. That's very important to remember. For B, what is the order of reactant Y? So now we are going to do a very similar process that we did in A. This time though, we're going to choose two experiments where Y is changing and X is constant. So experiment 1 compared to experiment 2, X has a concentration of 0.1 for both those experiments, whereas Y is doubling when you compare 2 to 1. Then you look at the rate and see what happened in the rate. We see that the rate is actually quadrupling when you compare experiment 2 to experiment 1. It's going up by a factor of 4. So let's think about that. X is constant, Y was doubled when we compare experiment 2 to experiment 1, and the rate quadrupled. It didn't even double. It didn't even go up at the same rate. So that has a particular meaning. Okay? If when you double a reactant concentration, you get a rate increase of a factor of 4, or a quadrupling, we're going to say that that is going to be an overall, or sorry, a reactant order of 2. If the order would have doubled, if the rate would have doubled with doubling the concentration, that would be first order. So we don't see that in this problem, but for future problems, you'll probably see something like that. So if you ever see that the order and the reactant concentration go at the same rate, that is called first order. Back to this problem, C, what's the overall order? We just add up the two orders for X and Y. X was 0 order, Y was second order. There you go. You got a second order overall reaction. For D, we're going to figure out the rate equation. Okay, basically we're just plugging it into that general format. We don't include X because it was 0 order. So rate is just equal to K times the concentration of Y squared, second order. With E, we're going to calculate the value of K now. We're going to figure out what that K is. So here, all you need to do when you're asked this kind of problem is you choose an experiment. You could choose any of these up here, and you figure out, you plug in the information to figure out K. So the rate is the beginning there. It's the 4.0 mole per liter second equals K times the concentration of Y, which is 0.2 squared. Now we don't include any X again because the reactant is 0 order. So we're just going to do a little algebra. I'm going to cancel out my concentration of Y and my 0.2 molar on both sides. And I get K equal to 100. And the units are important here. It's liters per mole second. Okay? Second order reactions will always, always, always have this liter per mole second K units. So sometimes you can just look at the units and know the order of the reaction. Here's a quick little side math of how I got those particular units when I squared Y concentration and moved it over to the left side of the equation, if you want to work that out. You can also just memorize it. I suggest you do for 0, first, and second order reactants, what are the units for K. So again, it's always going to be liter per mole second. There's a table that's included on your practice problems for this unit that has 0, first, and second order K units. Memorize those. Finally, F wants us to plug in some information and solve for the rate. So now we know what K is. We figured that out in E. It's giving us the concentration of Y. We're just going to plug and chug. So again, K was 100 liter per mole second. Concentration of Y in this problem is going to be 0.25 moles per liter, or molar. X doesn't matter again, it's 0 order, so we're not going to include it in the rate law. Rate, therefore, equals 100 liter per mole second times my concentration Y, 0.25 moles per liter, squared, and I get a rate of 6.25. The units are mole per liter second. And if you're going to compare those units to the table at the top, you should match the same units. Thanks, guys.